Hi everyone, welcome to my session. Today we're going to talk about how to convert your batch code to streaming code using the same platform without changing the code base itself. You will find this session very interesting since it's a unique technology I'm going to present today, which is open source. First of all, let me introduce myself. My name is Bobur, or you can call me Tiger, which is in English. I am a lead developer advocate at Pathway, and I have some experience also working with developer audience. I'm professional in software and data engineering. If you would like to have a live chat with me, feel free to connect me on LinkedIn. Here's a QR code I'm leaving it out for you. So let's jump on the session today. You know what, like big data unified architecture, as you can see in the screen, has lots of tools and technologies nowadays available. And this area where rapid changes are happening, right? Each of these tools and technologies has certain strengths that makes them right choice for the particular scenario. However, they could be a terrible selection for different use cases. And the technology I'm going to introduce you today, it's called Pathway. Which allows you to build a data pipeline to process your data in the application layer, which means your data stays where it is. You don't have to use spatial dedicated databases like a streaming database or vector database to work with your data. In reality, how this works, let me tell the story. When you're building data processing pipeline with Pathway, it's like manipulating static data. Then you get, when you get really big data, and it's really easy to switch to streaming mode. And Pathway can manage all the updates for you. What does it mean for your code in this case? You write a Python code. In practice, you need to use provided some built-in connectors to plug the Pathway over your data streams, like data sources. It can be any structured, unstructured, maybe semi-structured, or live data sources. Then you start to build your pipeline in Python using the Pathway APIs. And you just build a pipeline with the tables. You only need to build your pipeline once, which we call it like a YOBO. You don't have to change this code again to make it like to make it run in batch mode. That's the power comes in, and it will automatically these updates maintained by Pathway engine as data changes and data change is detected in your data source, and Pathway can reflect this data change on the Pathway tables, so you don't have to worry about if your data changes over time. So here, another gift, it also shows, as you can see, Pathway is proposally designed to work with streaming data. However, when you're writing your code for data processing pipeline, you need to also test your code, debug your application to understand what's happening with your data. So you can easily switch between two modes just by clicking and changing one line of code. And also the building this data pipeline, as you can see, it's very easy. So in conversion between static data and infinite data is manipulated by the Pathway with just one single line code, as you can see at the end of GIF, pathway.run. And what about the other people thinks about the Pathway? What are other use cases in the real world? I'm going to talk about them shortly. The Pathway is powered with a Rust programming language, which is very good for streaming engine, right? It achieves high throughput with low latency. And the Pathway itself can be written and tested interactively. You don't have to create a cluster like in Databricks, for example. You don't need a specific infrastructure. You just add the Python code or Python library into your Python application and you are good to go. And also, from the other hand, Pathway also simply reduce the cloud cost when there's a frequent batch computation is sometimes eating away your data budgets. So in this case, you can introduce the Pathway as additional layer, which is for free and open source. The code is available for everyone. So, and also it reduces, on the other hand, the number of data professionals working within your team, because we know that some data engineers are sometimes working on building batch data processing pipelines and streaming data processing pipelines. If you think about like a Lambda architecture, in this case, you don't have to worry about two different cases. Like, for example, you take a Apache Flink. In this case, Apache Flink also a little bit lacking with streaming data in terms of performance. Also, we do have a performance analytics where our pathway is far away than the Flink provides. And how things work in this case, like if you have a data source, you map each data row from that data source into structured table, as I mentioned it, to define some schema for your table, and pathway updates the results whenever row is added or removed from that table. So here, some tables can be created from Pandas library or CSV, other data sources such as Kafka or Redpanda to ingest real-time data. Or if you cannot find any existing built-in connectors, you can build your own custom connector in the same code environment. In this case, you can also build some maybe streaming as APIs, external APIs, connect the streaming API to your data. After your documents are loaded into table, you can transform each table row, column to any form dynamically. Like you can filter data, transform, join multiple streams, or reduce them using built-in functions. So we do also provide within this Pathway open source project real-time indexing, which is very good for building LLM applications. In this case, you don't need space figure storage. We use locality sensitive hashing called LSH as a classifier for our KNN, key nearest neighbor search, which is very effective in both semantic search and vector indexing. And we combined it in August recently, this Pathway open source as a technology for the streaming data processing with another open source project called LLM application to build AI data pipelines for your real-time data, where you can our AI application can react on real-time data changes. From the code perspective, if you're a Python developer, it's very easy to implement. You just write a couple of lines of code, as you can see in the screen. Like you ingest the data, you get some vector embeddings as RAG methodology says, and based on the vector embeddings calculated, the application does real-time indexing, and you can build some prompt and send this prompt to completion endpoints, and building maybe one or single or multiple LLMs from multiple LLM providers like OpenAI. So in this case, what it gives you as a good output, you can get rid of complex modern LLM stack. Like you don't have to use vector seek operators or vector storages, line chains like LLM frameworks, LLM caches or API builders. It gives you capabilities to put everything into one single platform where you can build your application without thinking about many technologies or frameworks. That is the application what I built, for example. What about quickly summarizing your content, get the information you need in real time from private, large, unstructured documents in your Dropbox? And I built this tool to search some useful information that sometimes it's very hard to find in PDFs or some unstructured data or PowerPoints. And this tool can be used with Google or OneDrive. You can give a try. I'm leaving out useful links if you would like to try also the pathway to build your own LLM application. Please scan this QR code, and it brings you some showcases, samples, tutorials that helps you to get started with both Pathway and LLM application. And then here are the takeaways from this talk. Pathway, as we say, that it's just a framework. It provides a unified platform for batch processing, stream processing, and also building LLM application. And Pathway has an amazing performance in streaming benchmarks and exactly outperforms also Spark in batch processing and streaming against Flink. So, and in this case, I will give you choices to get and investigate, discover more other solutions like a Pathway to build the fastest data processing for your unified workflows. So with that, I'm going to finish my talk. Thank you for your attention. I was super excited. So let's stay in touch. Bye-bye.